Welcome everyone to our video on mass and molar mass. This video follows our two videos on the mole concept, so if you haven't watched those videos yet and you don't even know what a mole is, please watch those first. In this video, we are going to learn how to calculate the molar mass of any chemical element and any chemical compound as long as you know its chemical formula. Before we get into masses and molar masses, let's do a quick refresher on the masses that are on the periodic table. Recall that the masses on the periodic table are actually average atomic masses. They are based upon that relative scale where hydrogen set as 1 and every element is weighed, quote unquote, relative to it. And that all goes back to Avogadro's hypothesis. They're averages because it is an average of all the known isotopes. For example, carbon has an average mass of 12.011. Now, most periodic tables do not write in the unit because the unit isn't incredibly important, but these units are called atomic mass units. They're just relative units where hydrogen set essentially is 1 and every element's based off of that. So carbon has an average atomic mass of 12.011 AMU. Okay, so now that we've had that refresher, let's go back to the question I posed in the last video where I asked, if the mass of one carbon atom is equal to 1.993 times 10 to the negative 23 grams, what is the mass of 1 mole of carbon atoms? Remembering that 1 mole is equal to 6.02 times 10 to the 23 atoms. Let's flip over to the whiteboard and solve that problem and see what we get. I've written the given information already. The mass of one atom, 1.993 times 10 to the negative 23 grams. And our task here is to find the mass of 1 mole of carbon-12. The math that's involved in chemistry is all based upon ratios, which should not be surprising because atoms and molecules all react based upon ratios. As we move through this unit, there will be formulas that you can use, but at its basic level, it's all about setting up ratios. And if you can figure out how to set up a ratio for a problem, it will help you in the long run of understanding what is happening with all of the quantitative chemistry we're looking at. So let's set this up here. One atom equals 1.993 times 10 to the negative 23 grams. And what I'm interested in is finding the mass of 1 mole of carbon-12 atoms. Now we know that 1 mole is 6.02 times 10 to the 23 atoms. So this is a ratio that's set up. I'm comparing the mass of one atom to the mass of a huge number of atoms. When you set up a ratio, you need to have equivalent units on the numerator and denominator. So we're comparing the same things. One atom is this many grams. I want to find out the quantity of this number of atoms. So that's why I changed it from 1 mole to the numerical value for a mole, because a mole is a different unit than an atom. So 1 atom to 6.02 times 10 to the 23 atoms. And then I'm trying to find a mass, and this mass was expressed in grams. So my final mass is going to be expressed in grams. So take a moment here and find that mass. Okay, solve for the unknown m. So I've rearranged the equation to solve for m. Now, you might be able to do that in your head, but I want to show you all the steps here. So here we have the rearranged equation. I'm just dividing by 1, so that's not going to change anything. I cancel those units there, so I'm going to end up with a mass in grams. So essentially the operation here is multiplying the mass of one atom by Avogadro's constant. And when you multiply those together, I'm just going to round this for the sake of simplicity. We end up with 12 grams. I know you'll get a value slightly under, but for the sake of simplicity, I'm just going to round that to 12. So we found something very interesting there. The mass in grams of 1 mole of carbon atoms was equal to 12 grams. Why is that interesting? Well, it's the same numerical value as the atomic mass of 1 carbon atom. So the mass of 1 carbon atom is equal to 12.0 atomic mass units. The mass of 1 mole of carbon atoms is equal to 12 grams. Well, this is not a coincidence. This is the reason the mole was selected to be 6.02 times 10 to the 23. The value of the mole was chosen so that the mass of one atom of any chemical element in atomic mass units is the same numerical value as the mass of 1 mole of that element in grams. So now we can figure out how to determine the molar mass of any chemical element. Because by our previous definition, the molar mass of a chemical element is simply the numerical value of its atomic mass. So to determine the molar mass, all you need is a periodic table. Let's do an example here. Let's find the molar mass of silver. So here we are from the periodic table. It does not matter which one we're going to use because for all of these molar masses, we are always going to round them to 1 decimal. So even if you have a value like this one, 107.8682, we're going to round it to 1 decimal. So the molar mass of silver is 107.9 grams per mole. The atomic mass of 1 silver atom is 107.9 atomic mass units. By definition, the molar mass is 107.9 grams per mole, or 1 mole of silver atoms has a mass of 107.9 grams. Now that we've seen that the molar mass of every chemical element can simply be found by looking at the periodic table, we can start building up into creating chemical compounds and determining the mass of a mole of any chemical compound. Let's think back to our definition now of a chemical compound, which is it is a combination of chemical elements in a fixed ratio. The fixed ratio is important. For example, when we talk about a water molecule, the composition of that water molecule does not change. One water molecule always consists of 2 hydrogen atoms and 1 oxygen atom. It's H2O. Never changes. This is important because if the composition of compounds is fixed, then the molar mass is going to be fixed as well. To calculate the molar mass of any chemical compound, you find the sum of the molar masses of the elements that make up that compound. Let's look at an example. Here we go, water. The molar mass of water is going to be the sum of the molar masses of hydrogen and oxygen. But we also have to take into account that there are more than one hydrogen atom. Water is made up of 2 hydrogen atoms and 1 oxygen. So the mass of the entire molecule, 2 times the molar mass of hydrogen, plus 1 times the molar mass of oxygen. Of course, we get those values off the periodic table. We plug them in and sum the values. So the molar mass of water is 18 grams per mole. We can say that another way. If you have 18 grams of water, you have 1 mole of water molecules. Let's look at an ionic compound, aluminum sulfate, which has a more complex chemical formula. So let's find the molar mass of aluminum sulfate. This would be a good chance to see if you're following along here. Pause the video and use the periodic table to find the molar mass of aluminum sulfate. The molar mass of any chemical compound is the sum of the molar masses of the atoms that make up that compound. In aluminum sulfate, there are 2 aluminum atoms. There are 3 sulfur atoms. And then there are 12 oxygen atoms. In each sulfate, there's 4, but we have 3 sulfates. 3 times 4, there's the 12. So 2 times the molar mass of aluminum, plus 3 times the molar mass of sulfur, plus 12 times the molar mass of oxygen. Right? The molar masses of each element we pull off of the periodic table. The numbers we're multiplying them by are the numbers of that type of atom in the formula of the compound. A few notes here. On the second line, note that the molar masses I pulled off the periodic table are rounded to 1 decimal place. When you take them off the periodic table, round them to 1 decimal place at that point. My final molar mass of a compound is also expressed to 1 decimal place, and the units are always grams per mole. Throughout this video, we have calculated the molar mass of 4 different substances, 2 atoms and 2 compounds. I've put these all in a chart so we can compare what's similar and what's different. When we're calculating the molar mass, we are always talking about the same number of particles. By definition, 1 mole of a substance is 6.02 times 10 to the 23 particles. I use the word particles here because some of these substances are atoms, some of them are molecules, and the aluminum sulfate is a formula unit in an ionic compound. But 1 mole is referring to 6.02 times 10 to the 23 particles. However, since we're talking about different atoms and molecules, and these particles are all different, and they're made up of different atoms, the mass of that same quantity of particles varies greatly. 6.02 times 10 to the 23 carbon atoms only weighs 12 grams, whereas 6.02 times 10 to the 23 aluminum sulfate units weighs 343 grams, so over 10 times the amount. So we see what's the same and what's different. When we're talking about molar masses, we're talking about masses of the same number of particles. However, the masses are going to be different because the composition of those compounds are different.